So what's my latest development? It's actually an application, Bitcoin anomaly detection using ARIMA models. This is an app that I built, and let me show you how I actually run the app. So if you're following stocks, you know that the price varies over time, and one of the charts is called a candlestick chart, and I can set the range that I want to search by. Like, let's look up through like yesterday. And we can look at the we can look at different days. Like, let's look at a recent date on 6/27. This is the daily. This isn't the. This is a few days leading up to that. So this is the month of June. You can see the price was generally decreasing over time, and the red, I think, are when the price goes down, and the bars is the volume that's traded. And then the height is the y-axis is the closing price, and the bars represent the trading volume. So you can see on June 24th, there was a high trading volume and the price decreased. And then these bands are the confidence interval. So here you can see the sensitivity is a little bit higher, so there's fewer anomalies. These red dots are dates when the stock price goes outside of the confidence intervals, and that is created using a auto-regressive moving average model, which takes the average of the stock price as well as a regression on the historical prices, where the time is more recent gets a heavier weighting and the older prices get less of a weight, so it creates these sort of smooth trends. You can also so the way that this is running is actually on RStudio server. So if you just type this into your browser, you can actually connect to the server 54.174.16.48787. And it starts off with it's called RShiny, and it has 2 pages. This UI, and then there's also a server. There's a server and a UI. So this UI defines the different elements of the page, like the title on the top, and then the main panel here. These are the sliders, so this is the min, the max, and the values. And then the date range here is just a function, date range input. Everything is based on functions. And then the panel here, you can add in different panels, and these other types of charts come here. So this is all very polished. And then the server, this is where it actually pulls in the data that comes from what's called the tidyquant here. Tidyquant is the library, so you can change this to pull in any type of stock, really. And then there's some other packages here, like zoo and forecast are what create the prediction model, and these other dplyr, readr are just utilities for manipulating the data. And so this is where I set the global parameters, and then this is the actual time series model. So it's this part here that says auto.arima. It's taking it actually takes the log, the natural logarithm of the current data, and that's why the base, because if you say that the closing is log normally distributed, when you take the log, you can fit the time series model and it calculates the raw non-standardized residuals. So that's what it's doing. Current data minus exponent of model fitted. And then you take a placeholder for calculated residuals, and then outliers are classified by those above the sensitivity level. You can identify the anomaly events, and then you have to catch an error. Like if there's no error events, you don't want the whole app to crash. Then put all this together into a data frame. Calculate the upper. So it's using upper and lower 90% confidence interval and smoothing them out. So that's it's taking the value plus or minus alpha times the standard deviation of the error plus the mean of the error. So yeah, that's how you can see where it's detecting the anomalies. And then you create the points for the red dots on the plot by saying where they occur. Right here. Then you create a table for the output, and a plot object is created with ggplot. So you have the closing price, and then the confidence bands, the anomaly events, and so forth. And then this is just the server output. That it's a server output is a function of the inputs. Like you can see, it's input $alpha. That's like the way that you so it's dynamically updated. What you can see is the SDK RStudio that's creating the application, and this is how I start and stop the app. In addition, you can see that I have the a Linux machine that's running the app. So this is the server. So here you can see port 8787 RStudio server is running. And this is just like a very basic setup, where if I just press ls for list, it tells me the different applications here, and the only things that I have is just I downloaded RStudio server, and I have 2 scripts. So that's very efficient. It's like, yeah, so here you can see it on the desktop too. So I just have this is the EC2 instance right here. It's pretty straightforward. Well, for a Amazon Web Services build. Here you can see the usage over time. So this has just been the last few hours while I've been developing it. The network, the CPU. So if I had to scale this up, if I had more people connecting to it, then I would have to make a larger instance